So, dear students, welcome to another lecture of Basic Electrical Engineering. In this lecture, we will discuss about the three-phase induction motor. Our prime objective of this lecture is to discuss about the three-phase induction motor, its types, construction, and some advantages, disadvantages, and applications. So to start with, what is a three-phase induction motor? So first of all, we need to understand that based on the supply that is provided to a motor, we have two types of electric motor. So one is the DC motor and another is the AC motor. So our purpose is to understand a motor which is the part of AC motor. So in AC motor also we have synchronous and induction motor. It is also known as asynchronous motor. Now this further is of two types. One is single phase induction motor, and then we have three phase induction motor. So we will discuss about the three phase induction motor in this particular lecture. So as it is clear that an induction motor or a three-phase induction motor is a type of AC motor, that is, an AC supply is given to a three-phase induction motor and we get the mechanical output. So this mechanical output is obtained in terms of the rotations per minute, the RPM. Now, so this type of motor is very important motor as far as the industrial applications are concerned. These motors are actually used as the prime movers in most of the industrial applications. Prime mover here means the prime element. So when we talk about the electrical drives, in electrical drives, the prime component is nothing but the motor, right? So if we have some AC drives, so AC motors are the prime component. Prime mover means it is used as a prime source to rotate some load. That means motors are coupled with some mechanical load, and when motor rotates, it also make the load to rotate. As I have already mentioned that there are two types of induction motors. The first is the single phase induction motor, in which we have only one phase, or you can say that which works or operate on single phase supply. Then we have three phase induction motor, which is the topic of our lecture. Three phase induction motors are mostly used electric motors in industries. Three phase induction motors are also used in the tube wells, basically to draw water, underground water, for the irrigation purpose. So you can take that as an example. So there is a feature of three-phase induction motor, and that feature is that they can operate or they can run on a speed from no load to full load. That means even if they are at load, or that means even if they are loaded or they are not loaded, their characteristic is that they can run on constant speed. You will not find the variation in the speed of an induction motor. This is the beauty of these motors, and because of this advantage, because of this feature and characteristic, these motors are preferably used in many applications. Now, because the speed of an induction motor depends upon frequency, now this we will discuss in the working principle of induction motor. So, it is quite difficult to have the speed control of these motors. It's not that we cannot control the speed of these motors, but if we compare this with the DC machines or DC motors, so we will find that it is quite easy to control the speed of a DC motor rather than an AC motor, specifically a three-phase induction motor. The construction of three-phase induction motors is very simple. They have a robust construction. Their price is quite low. That means they are cost effective, and it is quite easy to maintain these type of motors. Now let us come to the construction of the three-phase induction motors. As you can see in these diagrams here, these diagrams represent the three-phase induction motors. You can see induction motors around you. Your fan is an induction motor. Your cooler fan is an induction motor, right? Similarly, your microwave has an induction motor. Your refrigerator has an induction motor. Your uh, washing machine has an induction motor. So you will find the applications of induction motors in your daily life. But fan is, or all these applications are basically, in all these applications we use single phase induction motor, not three phase induction motor. Only single phase induction motors are used in domestic applications. So now, as far as construction of uh, the three phase induction motors is concerned, like every motor, induction motor or three phase induction motor also has two parts. One is the stationary part, which we generally call as the stator, and another is the rotating part, which we call as the rotor. So, alike DC motors, AC motors, that means induction motors, do have a static part, that means a stator, and a rotating part, that means a rotor. However, these induction motors are quite different from DC motors based on some aspects, such as in DC motors, the stator which we use serves the purpose of enclosing the armature. The same is done in induction motors also. That means stator serves the purpose of enclosing the rotating part. But in DC motors, we have the field system mounted inside it to generate the flux for the DC machine. and the stator is not made up of laminated sheets. However, in case of induction motors, the stator is actually made up of laminated sheets, and that is why we say that it is a laminated stator. We do not have any commutator in AC motors, and it has a uniform and small air gap. Now what does it mean? It means that, like, if in DC motors, like if this is a stator, this is the static part, and here you will find a pole shoe. So pole shoe, you all know, is used to generate the flux. So it has some field winding here. Let us say it is a two pole machine. So in a two pole machine you'll have two poles. It is a field winding here, and inside this we have a rotor, right? So this is the rotating part. Now in DC motors, the air gap is not uniform at all. Here we have less air gap, and then here we have a large air gap. But in case of induction motors, if you draw it in similar way, we have the slots on the stator. Stator is made up of laminated sheets. Windings are placed in these slots, and here we have a rotor. So you can see we have a uniform and small air gap in case of induction motors. And the last is, induction motors can run practically at constant speed. However, a DC motor can have a wide range of speed, right? So we can easily control the speed of a DC motor. However, an AC motor only has the constant speed, and it is difficult to have the control of the speed of these motors. But it is difficult, not impossible. We have the techniques to control the speed of these motors. We have methods to do so. Now there are two electromagnetic parts of an AC induction motor. The first is the stationary part, which is stator, which I have already mentioned above, and then we have a rotating part, which is rotor. So let us come to the stator part. So this is the stator. This diagram represents the stator or static part of the induction motor, that is three-phase induction motor. As you can see here in this particular diagram, these windings which you can see are these windings are responsible for the flux generation. So similar to a DC motor, here also on the stator we have a field system. So these windings are provided with the supply, three-phase supply. So three-phase supply is provided to these windings, and through that three-phase supply, these windings produce or generate a three-phase flux. So that three-phase flux is available in the air gap inside this motor. And you can also see that we have these slots where we have put all these windings. These are the slots where we have put all this winding, and this winding has three-phase connection. This is a three-phase winding, right? Because it is a three-phase induction motor, and we have to provide three-phase supply to this machine. Okay, so now how this stator is made, that is the question now. So as you can see here in these two diagrams, figure 1 and figure 2, this is a real diagram of the stator of a three-phase induction motor. This is a pictorial front cross-sectional view, right? As you can see, this is the stator sheet, one sheet. So we have n number of such sheets which are stacked, which are insulated, laminated, right? So we have these laminated sheets, and these laminated sheets are connected together to form this type of structure. So as you can see, we may have some n number of sheets which are joined together to get this type of structure. So these are the slots here. As you can see, these are the slots. These slots are used to put these windings. These windings, copper wire which you see here, these wires are placed in these slots, and we provide a three-phase supply. As you can see in this diagram, here we, we have the terminals where we can connect the three-phase supply, so that this three-phase supply can go to these windings, stator windings, right? So we have stator slots here, and this is the rotor lamination sheet. Rotor is again made up of laminated sheets, right? In some cases we have a different type of rotors. We will discuss in the next slides about rotors. And this slot is provided for the shaft, and we have, you can see here, the air gap. This is the air gap, this is the air gap, this is the air gap, this one. Okay, so as you can see, we have a small and uniform air gap between the stator and the rotor, right? So stator as well as rotor is made up of laminated sheets of ferromagnetic material, right? Because rotor cuts the flux when it rotates, stator provides the flux to the rotor so that rotor can rotate. As we all know that the principle of a motor, or the principle to get the motor action, is when we put a current carrying conductor in magnetic field, this current carrying conductor experiences a force, the direction of which is given by Fleming's left hand rule, right? So outer cylindrical frame, right? So we call it as yoke or stator. It is an enclosure which provides, as you can see here, it is an enclosure which encloses the rotating part, that is rotor, as well as it also provides flux to the rotor so that the rotor can rotate, right? And it is made up of cast iron, steel, cast aluminum alloy. All these materials are used to make the stator, or the static part of the motor, induction motor. Then we have the magnetic path. Now what is the magnetic path? Magnetic path has this this laminated stator which is made up of ferromagnetic material. This is used to conduct flux in the motor. So we need to conduct the flux, so we use ferromagnetic material, and that is why, and this particular part provides the magnetic path to the magnetic flux so that it can be linked with the rotor, and we can have the motor action, right? So these are the diagrams for stator. Then let us, and these diagrams, as you can see here, we have two types of diagrams. As you can see in this particular stator, this is a stator, this is the stator winding, right? And we have these slots here, you can say, this is the laminated stator slots here, right? These one, and these are the stator windings. But the difference that you can see in these two types of stators is that here we don't this stator outer part is totally smooth, and that is why we call it as a smooth yoke. But here we have a ribs basically, so you can see these ribs are there. Ribs are generally provided to have the rugged construction. Secondly, to dissipate the heat basically which is generated inside the motor. uh, so by providing these ribs on the outer part of the stator, we have uh, increased the surface area of the stator, so that we can have the maximum dissipation of heat which is generated inside the stator. So we put the insulated electrical wires, or copper wires or electrical windings inside these slots. Okay, these slots here, right, as you can see in this particular diagram, in this particular diagram, and in this particular diagram. This yellow is nothing but this is a cloth which is used. So cloth is used to cover the windings as well as to provide a cloth insulation to the windings, right? So now these are some points about the induction motor. So the windings of the induction motor can have a star connection or delta connection. This we have already covered in unit number 2, right? So you can refer unit 2 to understand the star connection and delta connection. So because it is a three-phase motor, it needs three-phase supply. So as far as three-phase supply is concerned, we have this three-phase star connection, we have three-phase delta connection. So these are the views of stator. Now let us come to the rotor part. So as you can see, rotor is the rotating part of the machine, right? Electrical machine. Now we have two types of rotors as of a three-phase induction motor, and based on these two constructions of rotor, we have two types of induction motors. One is the squirrel cage induction motor, which is in figure number 5, and then second is wound rotor induction motor, which is figure number 6. This is also known as slip ring induction motor, SRIM. Now, as far as the rotor construction is concerned, we have these two shapes. This is the cage rotor, this is a wound rotor, right? Now why it is called as cage rotor? As you can see, it looks like a cage. So we have these end rings here, we have these end rings here, and we have put the conductors. These are the conductor bars, these are the conductor bars, right? So this resembles a cage which is used for squirrel, right? And that is why it is called as squirrel cage induction motor. And this motor is widely used in industrial applications. You will find a lot of applications of this type of induction motor, right? So three-phase induction motors has two categories. One is the squirrel cage induction motor and the second is wound rotor induction motor, and these categories are based on the construction of the rotor of this machine. So we have squirrel cage type construction, we have wound rotor type construction. In wound rotor construction, we have the almost similar shape of the rotating part. You can see we have skewed type bars which are placed, and then we have end rings here like this. This is shaft, but the difference is that we have slip rings in this type of motor, and in squirrel cage induction motor we don't have any slip ring, right? Now as you can see, this is a real picture of a cage type rotor. As you can see, these are the iron conductor bars, right, which are skewed basically. Skewing is done to have some benefits of it. We have certain advantages. of skewing the conductor bars. So these are the conductor bars, right? And these are the end rings. This is shaft, and this is the end ring. So all these, and we have here also we have an end ring back to back, as you can see here, this end ring and this end ring, right? So back to back we have two end rings. These are connected and shorted, right? The conductor bars are shorted conductor bars, right? Now this is the expanded view of a squirrel cage induction motor. We have all the parts here. Cooling fan is there, and bells are basically the and enclosure to cover the induction motor from front and back, right? And this is the stator. This is yoke. It provides enclosure to the rotor. Inside this you can see we have the stator coil or stator winding. This is a rotor. This is squirrel cage rotor. We have ball bearings here. We have shaft, right? And this has all the parts, right, of squirrel cage induction motor. So, squirrel cage rotor consists of copper or aluminum bars installed onto the slot. So, we have these slots here. So, on these slots, we install or put the conductor bars of copper or aluminum or any ferromagnetic material also, right? But generally, the copper or aluminum bars are preferred. So this resembles squirrel cage, and that is why it is called a squirrel cage. Now the one of the important feature of this type of motor is that it has a very rigid construction. It is a very rigid construction. It is very robust motor as compared to other motors. It is very robust motor. Now these aluminum rotor bars, these aluminum, let us say these are the aluminum rotor bars, or these are the rotor bars. They are in direct contact with the steel laminations, right? Practically all rotor current flows through aluminum bars and not in the lamination. Now what happens? This conductor bar, which are made up of aluminum, will provide path to the current and not to the magnetic field, right? And these currents which are flowing in these, which will flow, we will discuss this in working principle of induction motor. So these conductor bars which carry current, though this current does not leak into the ferromagnetic material, right? Now why do we skew this? As you can see in this slide, these are skewed, right? So we have skewing of the material, skewing. Why skewing is done? Skewing is done so that we have a uniform torque and we have less noise while your induction motor is operating. When induction motor runs, you will hardly listen or hear the noise because of induction motor. Now, because of skewing, the rotor is not locked. It does not get locked basically. So we have maximum exposure of the conductors. As you can see, we have the maximum exposure of the conductors um, with the magnetic field. We will discuss this also in the principle of working, right? So these are the advantages of skewing the rotor. Now we have the next one, which is slip ring induction motor or wound rotor induction motor. Now, as you can see, the difference between a squirrel cage and a slip ring induction motor is that we have the windings placed here, right? And then we have slip rings. So these slip rings, as you can see in this schematic representation, so this represents the winding part, right? So these are the slip rings, symbolic representation is there. Now these slip rings are connected to the rheostat because it is a three-phase induction motor. So we need a three-phase resistor or three-phase resistance or rheostat basically, so that we can connect all these slip rings, all these three-phase windings to this rheostat through slip rings, right? So because it has slip rings, so that is why we call it as slip ring induction motor. Now these resistances have certain advantages, they serve a purpose here. Why do we have these resistances here? The first reason is that these resistances help in increasing the starting torque of the induction motor, and hence, uh, see, when the starting torque increases, so the motor needs more current. Okay, so the current will also increase. Now if the current increases, so it may lead to the heating of the motor, so motor will get more heat, will get up more heated, right? So to reduce this effect, starting torque will increase, but these resistances will limit the starting current. So hence the starting current will be low, which will lead to the low heat generation in the motor. And the second reason of using this rheostat is that we can have control on the speed of the motor by using these rheostat, right? As you can see in this diagram here, we have fan, we have and bells here, we have rotor, ball bearing, this is shaft, this is stator winding, this is yoke, and from here we give supply, right? So we have all these points are mentioned here in this diagram. You can see this is the cross sectional view. So apart from the rotor and stator, we have some other parts of the induction motor, like we have this and enclosure, we have this fan. Okay, so fan is used to exhaust the heat, so it exhausts the heat, it removes the heat generated within the motor, it removes this heat out of the motor and keeps the motor cool. However, we also have some other mechanism to cool down the motor. We have these ribs basically. So when air flows through these ribs, because these ribs carry heat, and when air flows through these ribs, uh, this air will take away the heat from the motor. Okay, so we have stator, we have rotor, we have fan. So these are some other parts of the induction motor. So we have bearings with this, we have shaft is there, shaft is made up of steel, right? So it is used to couple, so this shaft is coupled with the mechanical load, right? So it is coupled with the mechanical load. So to get the to transmit this mechanical power to the mechanical load, right? And we have the cooling fan so that we can keep the motor cool, right? So to avoid any ill effect due to the excessive heat, so this excessive heat is removed from the motor with the help of this fan, right? So we have a terminal box also, either on the top of the yoke means, so this is yoke basically, the outer enclosure, right? Either this terminal box is available on the top, right? As you can see here, we have it on the top of the machine, or it is available on the side of the motor, right? So this terminal box is used to provide the electrical connection, that is three phase electrical connections to the uh, motor. Now, these two types of constructions of rotor, cage rotor and wound rotor, has certain advantages. For example, cage rotor. So cage rotor is quite cheaper, cost effective. Its construction is robust, rugged, simple construction it has. You can see in the diagram also. So in the diagram also you can see this has a bit complicated construction. However, a squirrel cage, like here if you see in this diagram, it has a simple construction. You can see it has a simple construction, right? So we do not have any brushes in these motors, so we don't have any kind of sparking. Now why we are saying it as that we have sparking, let us consider uh, DC motor. So in DC motor we have the commutator basically, which is segmented part. So with these commutators we have brushes, right? We have brushes. So when we connect an AC supply with these brushes, so current will flow here, and we have a winding with this. So this winding is like this, and then we have the north and south pole, for example. Okay, so the current will flow like this, it will go and come and like it like this, right? So now when this rotates, when this commutator rotates, these are the brushes. When it rotates, because these brushes are in contact with the commutator, so there will always be some sparking. However, in induction motors, since we do not have any brush, so there is no risk of sparking also. It can be easily maintained. We do not need a lot of money to maintain these motors. This is the beauty of these motors, and its power factor is quite good. Efficiency of the cage rotor is quite good, because if power factor is good, then obviously efficiency will be good. Now this wound rotor will also, this also has certain merits. The merit is that it has high starting torque. So wherever we need high starting torque, uh, wherever we have high starting torque applications, so we can make use of wound rotor type induction motor. Now it has high starting torque, but because of the resistances, because of the rheostat, which is connected to the three-phase winding through the slip ring, this motor has low starting current, because those three-phase windings are used to limit the starting current. So these resistances also provide a precise control of the speed of the rotor in case of three-phase induction motor. Now let us come to the advantages of induction motors. What are the advantages? Rugged construction, simple construction. This is one advantage. Three-phase induction motors are quite cheap. So if you use single three-phase motors and you use three single-phase motors, so one three-phase motor, three single-phase motor. So this will be very costly to you, because you are using three single-phase motors, right? So the work of these three single phase motor can be obtained from a single three phase motors, and hence it is quite cost effective. It can be easily maintained, and because its power factor is good, so its efficiency will also be good. It has very good starting torque, high starting torque, but it has certain disadvantages also, like because it has a constant speed from no load to full load, so we do not have a lot of scope to have the control of the speed of the induction motor, right? But then we have certain methods by using which we can control. However, we don't have a lot of scope, because the scope is very less. Starting torque is, as compared to DC shunt motor, starting torque is quite low. So this is the demerit or disadvantage of three-phase induction motor. Then we have the applications. Though three-phase induction motors are quite used in various types of applications, ranging from the applications related to small workshops to the large industries, right? Such as we have centrifugal pumps, we have conveyors, compressors, crushers, and drilling machines. So all these applications are where we will find the use of three-phase induction motor, right? So this was all about today's lecture. Thank you so much.